Fantastic, thank you. I'm very excited to have this opportunity to talk about this topic for the next 15 minutes or so. And I think it, in some ways, it dovetails a very different perspective I think I'm going to give you to the previous speaker. And in some ways, maybe a much more practical and maybe slightly shorter term vision for the future and how we might be able to change things. But hopefully you'll also see why it could accrue to a bigger, grander vision as well, because we just saw in the last presentation about the importance of hardware and hardware devices and how that changes how we interact with computer systems and ultimately how we interact with each other. So in many ways, what I'm talking about, I think, accrues to that. So I should probably start out by explaining what I mean, by interactive hardware, just to make it clear. We're talking about making new devices based on electronics, new electronic stuff. Typically, they have a microcontroller in them, and increasingly, devices are wireless, and they often have some kind of input and output because they're part of an interactive system. And to me, democratizing means a couple of things. So, of course, perhaps the most obvious is that it means making the hardware creation. That's what I mean, the creation of these technologies accessible beyond the electronics profession. So picking up on some of those questions we heard at the end of the last presentation, we want to allow people who don't have formal qualifications in electronics, who don't work in the electronics industry, to be able to create these new hardware devices. But I think there's also an opportunity to help people that do have experience in electronics by empowering them to build new systems more cheaply, more quickly, more easily than the current tools perhaps allow. And in particular, I'm interested in ways for doing this for low volume products. So of course, the good news is that over the last 15 years or so, we've seen all manner of tools and platforms that do just this, right? They democratize the creation of interactive hardware. One of the most well-known is Arduino, but of course, it's not just Arduino. This picture shows there's a Raspberry Pi here inside this box. And again, it's not just the board itself, but there's a whole ecosystem. So we've got solderless breadboards, and we can plug in these breakout boards and connect everything together with wires. So we're done, right? Interactive hardware democratized. Well, that's exactly what I used to think. So what happened? Well, I know it sounds a bit corny, but about 6 years ago, I started on a journey that ultimately completely changed my perspective on what it means to innovate with electronics. And so I want to tell you about that. Now, literally, it started with a journey. I went to Shenzhen for the first time. Shenzhen is the global center for electronics manufacturing. A crazy high proportion of the consumer devices that the world uses are manufactured in Shenzhen and in the surrounding region, Dongguan region. And on that trip and in subsequent visits, I was able to visit probably 100 different companies, factories, distributors, design houses, warehouses, startups. And I say they've given me a completely different perspective on what it means to innovate in this space. Before, I used to think that creating new user experiences based on hardware involved coming up with a concept, maybe using some cutting edge sensor that was suddenly available, or developing a new sensor, or leveraging some new display technology, then building a prototype and evaluating it. And I published lots of things like that at UIST and other conferences. But now I can see that I think almost without exception, it's equally important to understand how to manufacture that prototype. If you can't make more of them, reliably and cost effectively, ultimately no one's going to use it, apart from the people in your user study or maybe the visitors to your research lab. So any work you did creating a prototype and evaluating it is kind of meaningless unless you can understand what's going to happen next and plan for it. So returning to the topic of the talk, if you apply this broader lens that includes manufacturing, you realize that what we've done so far in the research community and with our colleagues who make and sell those prototyping platforms I mentioned before, largely is to democratize interactive hardware prototyping. We made it pretty easy to build a single artifact. Makers do it for fun, students and teachers do it to learn, and researchers like us can turn our device concept into working prototypes. but we haven't really addressed how to move from prototype to product. And that's the motivation for this presentation. So for several of the research projects I showed you before, we actually built hundreds of devices. And with hindsight, in doing that, we developed these ad hoc ways of scaling. But before that first trip to China, I never really thought very deeply about the process of production. But in China, you're immersed in it, right? And for me, it was a revelation. I learned so many things that I'm kind of embarrassed I never knew before. They never occurred to me before. And I don't have time to talk about all of them, of course. So I'm going to touch on just three today. I'm going to talk about manufacturing, test, sourcing, and compliance. So I think the thing that struck me most about manufacturing when I started spending time in China was the dependence on manual labor. This photo shows relatively low volume manufacturing, and you can see two operators here working on these boards that they've got in front of them. But even with the very highest volume production lines that you might think were completely automated, you'll see people everywhere. So I've been on production lines where they're making 1 million pieces of the same product every week, right? 1 million pieces a week. And you know, it turns out the surface mount machines can't solder all the components. The awkward to solder components are always soldered by hand. The PCBs that go into a product are assembled into the product, put in a plastic enclosure, and are screwed in by hand. And then the testing is often driven by an operator, like in the picture. The products are put into boxes, you know, by hand. So I actually went to a keyboard factory where every key of every keyboard is manually tested before the products ship. So of course they have a machine that the keyboard's plugged into that verifies all these button presses, but someone's job is to press all the buttons. So because of all this human labor, everything's prone to human error, which means that everything needs to be tested. And that testing process also needs to be very straightforward, and it needs to be fast to make sure it's cost effective. So to dive into this a little bit more, what you find is that testing invariably involves something like this. It's called custom tooling, like a test jig shown here. So what the operator does is they take one of these boards, they place it into the test jig, they pull this lever down at the top, and this is already in the down position, so there's a board in there. And as the lever comes down, these two layers of plastic here sort of sandwich together the board between them, and they're sort of sprung pogo pins that push onto test points on the PCB. Then the operator presses some kind of button on the test jig, and you know, a few seconds later, a light lights up. If it's green, the product's good. If it's red, there's some problem with it. So you can imagine, well, actually, sometimes designing this test jig is more complicated or more time-consuming than designing the product. And you can certainly imagine that designing the two in union, right? Designing them together is a smart thing to do. Often you might actually change the design of your product just in order to make sure that it can be tested more easily. And you might be surprised how many units actually fail testing. Again, we think that PCB assembly is like near perfect these days, but even on a very highly tuned production line that's making the same product day in and day out, the first time pass rate is typically only 95 to 97%. So that 3 to 5% of boards that fail the initial pass, you've got to detect them really early on. You can't afford to let them go out of the factory. It gets so much harder and so much more expensive to deal with it later. And you might be tempted to think, well, you know, my thing's only a research prototype, so I don't need to worry about manufacturing. And that's exactly what I did for many years. But with hindsight, for many of the more promising projects I worked on, I can see now that adoption was limited, often because we didn't take any of this into account early on. So I encourage everyone here, right, if you're working on new hardware devices, really think about this and make sure you get the right balance for you. So that's a glimpse of manufacturing test. Something else that becomes very tangible, I think, in China is component sourcing. This product here was successfully funded on Kickstarter a few years ago, and there's a really interesting Medium article about it, which I encourage you to take a look at. So it was created by a startup, and as you might imagine, you know, spent a lot of time getting everything just right, ready for production, and they're just ready to go. I pull the lever, start the production, and at the very last moment, it turned out that this LCD that they'd designed into their product was not available. They couldn't buy any. They needed to buy 500 units to build the units to ship their Kickstarter, but it wasn't made anymore. There were none in the supply chain. And actually, it turns out they were able to get the original manufacturer of this part to make some more. So I think that was pretty lucky that they managed to do that. And you might think, well, that's fantastic. So it all worked out perfectly. But of course it didn't, because although they could fulfill that Kickstarter campaign, they could never make any more of those units. They'd have to redesign the product. And the final topic I'm just going to touch on is compliance. And again, you might think, well, this doesn't really apply for me. This is just for commercial products, right? But even devices that you want to give to people to evaluate need to be compliant, right, with the rules and the regulations of whatever country you're going to do your user testing in. Now, compliance testing tends to be a bit of a pain. You have to book time in a special test lab. Often you have to do it a couple of weeks beforehand because they get booked up. It's certainly not cheap. And when you get there, it often takes a lot of time to set things out. You're in and out of this chamber, this test chamber you can see in the picture, like making changes, and it's all quite time consuming. So, and then at the same time, like when you're building your early prototypes, you're just refining them in the lab, then you probably don't need to do compliance testing at that stage. So it's very easy to leave it until the very last moment. But actually, at that point, you might find that the way you made early design decisions, they've kind of backed you into a corner, and it's not easy to make a simple change to fix any non-compliance issues you have. So the sensible thing to do is actually to do what's called pre-compliance testing, which is like a lighter weight version, but it still involves going to the lab, and you do it on your very first prototype, and you do it periodically, so you don't get any surprises towards the end. So at this point, there's 3 different things I've touched on there, which are really important when it comes to scaling from your prototype into, even if it's only low volume production. And at this point, you might be thinking, oh my gosh, how are we ever going to democratize all of that, right? It seems like there's a lot of domain expertise needed, a lot of bits, moving pieces to fit together. Well, I think the good news is we can take inspiration from the software development community. While many of us hardware folks have been somewhat focused on perhaps on these prototyping platforms, our software colleagues have developed what we call Devops. So this can mean different things, but of course the basic idea with Devops is to bridge between the design of a product and its delivery. So on the left-hand side here, we have the software development cycle where the product's designed, and on the right, whatever the software experience was, it's delivered to customers through some kind of operations infrastructure. And generally, what the developer does is they benefit from much better visibility from the operations side of things. And this visibility into operations can actually manifest itself in quite different ways, right? The different aspects of what it means to operate. So first of all, the developer might get some kind of continuous feedback about the servers that are deploying their product. They might get to see the workload or the memory footprint. And so they might refine their software product on the basis of that. They might choose what to try and make more efficient, for example. But in a completely different aspect of the feedback you might want is usage information. You might want to know how people are using your product, which features are the most popular, so you can focus your further development efforts in the right direction. And I think what we need are DevOps, but for hardware. We want to create a more fluid transition between this prototyping phase on the left and all those operational issues I talk about. So if we zoom in a little bit, you can imagine maybe in the case of manufacturing test, we could have an open source library of jig designs, and then the developer over here could design and develop the jig in parallel with the product itself, rather than leaving it up to the factory to build the jig later. So the designer picks an open source design for a reference design for a jig, and maybe forks it, customizes it to suit their design, and then the developer can do can implement the equivalent of test-driven development. So as they're iterating their hardware, they can actually be testing it as they go, using the same testing infrastructure that ultimately is going to be used in the factory, creating this, making sure this this release process is much smoother, in the same way that DevOps in software does. So we're starting then to build a continuous integration flow and a delivery pipeline for hardware, maybe the equivalent of of a code review involves a telepresence session between the factory and the designer of the product. Maybe that could be supported by real-time language translation. And you can, again, you can imagine how that would give the developer much more insight, visibility into what's happening in the factory. It creates a much tighter loop that can be traversed rather than today when the developer physically has to go to the factory, right? Often they have to fly halfway across the world in order to have this deeper conversation. Can we make supply chains more transparent and easier to navigate? Imagine how useful it would be for designers to have a tool that provides information about the availability of parts, maybe suggest alternative parts that have a similar function, and then give them pricing, provide pricing for every part in your design. It would make it so much easier to select sensible components. Or how about making compliance testing so easy it can be used routinely throughout hardware development? You know, right now it's this kind of manual, tedious process that I talked about, but maybe we can make, you know, tools even just on the logistics side to make it easier. Maybe booking a testing slot in the EMC lab is as easy as placing an online order for a PCB. Perhaps we can even make it cheaper in the way that we pool PCB orders together by arranging to test similar products at the same time. Can we create some kind of Docker container that encapsulates all the information readily that's needed for testing, so the testing process itself is quicker and therefore easier and cheaper? If we can do some of these things, then as the development cycle iterates, we're doing this testing much more frequently. So if something starts to slip out of compliance, the designer will know right away. So these are just some of the ways I think that maybe we can create a more fluid transition between hardware design and delivery. I guess my vision is a world where it's much easier to build reliable, cost-effective hardware, especially for low volume production. I think this will enable much more innovation. It would let companies and individuals take more risks with the kind of new devices they design and develop. Right now, it's just too hard unless you're a professional electronics engineer making products in high volumes, you know, for a big company. But I think that between us, we can change this and ultimately democratize interactive hardware production as well as prototyping. Thank you.
Thank you very much, Steve. I'm pretty sure the chat is just now filled with people applauding. So I guess we are relying, as David said, on the visual sense. Wonderful, wonderful, very thought-provoking, and clearly very important talk. And it's led to a number of questions. Ken Nakagaki, who was doing a lot of research in Shenzhen factories at an MIT Media Lab program a few years ago, is asking, there's a gap between what happens in a lab, especially non-industry ones, and a factory. How can that gap be filled in, and what are the challenges and what are possible solutions?
Yeah, so I think in some ways, I think, well, maybe that's not the first place to start, but it's not a case that the lab would be the last place, I think, to see a benefit. In some ways, what the existing status quo is fine. It's actually really good for high volume manufacturing. So we don't necessarily need to change what people do at the high volume. The big companies that are making products like iPhones, or, you know, that is super highly optimized. But I think what we should do is really think about going to the other extreme. So what would you do in a lab environment? And I think there are, if you go to China, another thing that kind of amazes me is that there are literally thousands, tens of thousands of factories, of small factories. You know, sure, there's Foxconn that have, you know, a factory the size of an entire city, but there are a lot of smaller shops that are very willing to do lower volume production runs, but they don't, basically we don't have the connection to them. If we can make that transition between prototyping and that, you know, they're the operations side, if we can make that more seamless. So I think starting with some of these small companies is a great thing to do. So if you want to do, you know, it's research that we need to do in the first instance, but great research projects could involve creating collaborations between, you know, people on the design side, but also, you know, different factories, either locally in different regions around the world, or in particular with places in China too. And then I think from that we could, you know, do it at the minimum viable product style, where perhaps to start with, there's someone manually curating this process, but observing what's needed, right? What kind of communication happens, what design files are exchanged, what common things go wrong, for example. And then building on that to try and build tools to start filling these things in, and then almost come at two ends from it, right? Try and go from the right now. I mean, I imagine many of you who are prototyping electronic devices have worked with factories in China, right? You might well have done that, and you might well have worked with others in different places around the world. But so we want to start with what you've already done, and aiming, to get straight to what happens in mass manufacture. Gradually try and make it a little more and automate it in that kind of DevOps fashion. I don't know if that answers the question.
I think so. And then a question from, that was good, from Shohei Katakura from HPI. One of the things that is being asked is, what about people who are not mechanical engineers but want to build hardware prototypes? How do they deal with things like determining engineering tolerances of each part? How can they make use of their own domain knowledge as we try to go into the space where things become scalable?
Well, I mean, I think it's a very similar. I have thought less about that because I've been concentrating in some ways to start with. I'm starting more on the electronic side, and also not necessarily not trying to make iPhones this way, but thinking a little bit more about embedded devices, the microcontrollers. Again, it's part of my, let's start a little bit smaller and grow on that. But I think a lot of those principles I talked about could apply to mechanical engineering as well. So I'm actually working on a project right now where we're talking with a factory in China, and every now and then they say something that just doesn't make sense. And of course, it's just because we don't have the same kind of shared context. We don't have that visibility into all the manufacturing processes. It's like, well, hang on, I thought this was going to happen, and so why does this not work anymore? So creating better visibility, not just about how do I drive the CAD tool, or how might I make my one-off in my lab, but when it comes to machining something or manufacturing at scale, what's cost effective? What would you just? They have, again, on this project I'm working on, the manufacturing partner we have some incredibly default assumptions. They just do things in a particular way, and like, because that there's a reason behind it, but they don't tell you initially what the reason is. You've got to kind of really drill down to understand that. And if we have more visibility, I think that really helps. And another thing, it's not just being able to see into the production side, into that operations side, but be able to close the loop quickly. I know that I mean, it's like a decade or two back now. But I at some point I started, when I made a PCB, a circuit board, a bare circuit board, I started doing it online, right? Because up until that point, you would have to phone the PCB house and you'd tell them about your design, and they'd ask some questions, and they'd come back, half an hour later with a price. And you'd kind of be like thinking, oh, what happened? Can I make it cheaper? What happens if I make this change or whatever? And then you'd have to ask them again and wait another half hour. And it's really painful. So you just don't do that iteration very much. As soon as you have an online system, you're just talking to another computer, and you're quite happy to, like, I'm going to change the parameters. What happens if I do this? What happens if I do that? And again, it helps you understand. It creates more visibility. What are the impacts on cost in that particular case, or maybe lead time, or and if we have that for mechanical parts as well, not just for the prototyping, but also for production. Again, it helps us as designers understand, right? It closes that gap.
Mm-hmm. Very good. So Deshita Turakia asks, how might people, researchers in particular, be incentivized to include compliance? How do you see that might happen? Part of the evaluation process in papers and projects, or some other method?
Yeah, I think that's a really interesting topic. So what I've observed over the years is increasingly we care more about that as a community, right? I'm not talking about hardware compliance or FCC or anything like that, but in general we care about doing things right. And oftentimes now, if you're publishing work based on a user study, you might need to demonstrate that you had all the right approvals in place, that you carried out the user study in the correct way. Whereas 10 or 20 years ago, maybe that was less on people's minds. So I think increasingly we will see, maybe this actually comes in as part of one of the requirements for submitting a paper or reporting on work that was done, in user studies that were done with new hardware. It's kind of interesting because there's definitely, people, there's definitely a perspective like, well, I don't need to apply all that. There's a lot of red tape that doesn't apply to me. What's the worst thing that could happen? And a lot of those regulations, of course, really are designed to make sure at scale bad things don't happen. But nonetheless, some of them are designed to make sure bad things don't happen at all. We have building regulations to make sure that generally buildings are safe and they don't fall down. And sometimes we see what happens when people don't follow the building regulations. So I think it's also important for us to understand, what the rules are, and to make sure that we account for them in the best way that's appropriate, for the work that we're doing.
Thank you. Unfortunately, we have a little bit of time for questions, but we have many more questions we're going to get to. So I apologize to the people who are asking excellent questions that we're not going to get to. One of them, I think, that a lot of people have been thinking about is from Zhikang Liu, is what about sustainability? I mean, there's potential for labor exploitation. Even more things are widely adopted. How can we be thinking about those issues as we talk about scalability?
Oh, yes. I mean, I think that's a huge topic as well. So first of all, in terms of like labor exploitation, I kind of hope that this would go the other way. I mean, it's really interesting. We've heard a couple of times already in this conference, people reflecting on crowdsourcing and Mechanical Turk, and how initially people saw it as a way to get things done really cheaply, and now people are being a little bit more thoughtful about how do we make sure that the world we're creating is still the kind of world we want to grow up in, and we want our kids to grow up in. And I've spent a lot of time in factories in China, and maybe I'm just like too naive, but I've yet to see anyone that I thought was trying to make a quick buck, or take advantage of a situation. Now, of course, sometimes if you get something from a factory in China, and maybe you look at it and think, oh, that's not very good. But I'm convinced that the only reason that ever happens is because the person who made it didn't know what good was. If they don't know how to test it, how can they make sure they've got a high quality product? Or maybe they kind of know how to test it, but the testing process was so expensive, there's no way they could do it for the price that they're expected to ship. So I think in some ways, having more visibility for us as designers about what's involved in manufacturing can help set the right expectations, and then empowering the people doing the manufacturing with the right tools to ensure the quality is good. I think that can help. I think that can truly be a win-win. Right? Technology can help both sides there. And in terms of sustainability, I was just going to add, well, there's a couple of aspects to that. I mean, my hope is that by enabling lower volume production, then people can have devices perhaps which are more customized to their needs and maybe suit them better and help them last longer. But that's kind of, maybe that's a little bit wishful thinking. I don't have any solid basis, but I'm really interested to learn more about that and maybe do research in that area.
Right. So yes, and actually, Richard Lynn had suggested in a question, is it possible that we could be encoding knowledge into tools more effectively in order to democratize those tools and thereby enable the vision that you're discussing? Did you want to speak to that?
Absolutely. I think that is the key kind of insight, exactly. I think, we obviously need to extract some of that knowledge and then put it into tools. And that's what we do in software, right? So if you think about DevOps, kind of what we did perhaps as a community, the DevOps community took a step back and said, well, hang on, what's happening? What are the processes here? Who needs to see what? And then created an infrastructure, a flow, tools and processes that support, the best case scenario, right? That golden path. And I think we can do exactly the same with hardware. And I feel like maybe some of the reason we haven't is perhaps some of you guys are a bit like me. I didn't even realize this was a thing until, it's only in the last 6 years or so that I realized how important I think this is. And so that's kind of why I'm so excited at this talk, because I want to share my perspective. And if any of it resonates with you, or if you see value in the things I've talked about, I'd love to talk more. And I think there's a lot of research opportunity here to do exactly that.
Okay, I'm going to ask one last question. I'm going to combine several questions into one, and then unfortunately we're out of time. This is a combination of questions from Ranghao Liang and Jianen Li. So the sociology between researchers and manufacturers, how do we create a positive interaction between those, where the manufacturers are incentivized and interested in supporting what the researchers do, and the researchers are able to understand what the manufacturers do, and they don't end up just in completely separate worlds that don't talk to each other?
Sure. I mean, I think it's exactly the same thing. I think it's all about visibility. Shared understanding, right? Is what brings people together often is a shared understanding. And if there's tension between two sides, maybe between researchers and manufacturing people, it's probably because they just have very different perspectives and don't kind of almost talk each other's language. So when one person says something, it's not easily understood, right, on the other side of the fence, and vice versa. And so I think creating more visibility in both directions and allowing a tighter loop so that artifacts almost can be passed between them would create this shared understanding. And I think that's going to break down any tensions there are, any misunderstandings there are. Yeah.
All right, that's a brilliant, wonderful talk. Thank you for your insights from the future.